Carl Friedrich Gauss was one of the most influential mathematicians of all time. And this is an anecdote, probably a true story about him when he was still just a child, somewhere between 8 and 12 years old. The story is that his teacher gave him the following exercise. Take the numbers 1, 2, 3, 4, and so on, all the way till 100 and add them up. And it must have been a very frightening moment for this teacher, but little Gauss had the correct answer within minutes. And so the teacher asked him, what did you do? And so little Gauss explained the following. So you want me to find this sum? I'm going to call this x. And then he said, instead of adding up all these numbers and finding x, I'm going to do it twice. And at the end, I'm just going to divide by 2. So I'm going to write down all these numbers again, adding up to x. But when he wrote down the same line, he reversed the numbers. So he said, this is 100 plus 99 plus 98 plus 2 plus 1. And that should be x2. So the plan was, I'm going to add up all these numbers, and at the end, I'm going to divide by 2. But instead of adding the first row and adding the second row, he proceeded sort of column by column. Now what we mean by that is that 1 and 100 adds up to 101. 2 plus 99, that's 101 too. 3 plus 98, same sum. And if you look at the end, 100 plus 1, that's 101. And 99 plus 2, that's 101 as well. So it looks like what we have is that all the columns add up to 101. We just see these 5 columns. But here in the dot, 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 do we have a guarantee that every single column will add up to 101? And the answer is yes, because if you take a column and then take one step to the right, the first row will gain 1, the second row will lose 1, so the sum remains the same. And therefore, 101 added to itself many, many times is twice the number that we want. Now, when we're adding the same number to itself multiple times, we have multiplication notation for that, right? So we could rewrite this as 101 times what number? So the question is, how many columns are here? Well, if this is the first column, and this is the second column, this is the third column, and so it's pretty clear that we have 100 columns as we added up 100 numbers. So we can rewrite this line as 100 times 101 is twice what we want, and so what we want we will get if we divide by 2, which would be, this product is 10,100, and when we divide by 2 we get 5,050. This trick doesn't always work. For example, it won't work with the square numbers 1, 4, 9, 16. It will always work and only work when the numbers are increasing or decreasing by the same amount, because then you can play this property against itself by lining up backwards, and then the sums remain the same. Such a sequence of numbers is called an arithmetic progression or arithmetic sequence. Thank you for watching.